All right, everybody. This is going to be extremely awkward since I'm going to be the only one talking, but I guess that's okay because I'm used to being the only one talking to myself. So today we're going to go about ellipses. Hopefully you have looked through that PowerPoint by now and have written down those two charts. We're going to start by talking about what an ellipse is, how it's formed, so forth and so on. So if you are also looking at the slides going along, I am currently looking at this slide right here, talking about the ellipse, which basically starts to tell you that an ellipse is a set of all points in a plane whose distances are going to be a constant sum between 2 points. So what they mean by a constant point is that if you have a single length of string, that if you were to tape the two ends at two focus points, because an ellipse has two focus points, you can draw an ellipse. So I'm going to kind of demonstrate that and then talk about the different parts of the ellipse. So welcome people who are joining currently. So again, I'm going to start by showing you an example of how to make an ellipse. So I have this ribbon. I didn't have any string. That's still at school. So I'm going to take these two pieces, or two ends of the string. I'm going to label those my focus points. Wait, I need some scissors. Okay, sorry. So the places that I have taped these strings together are going to be the two different focus points. So what I can do is by stretching out this string, this distance right here and this distance is going to be the same as if I were to just bend it a little bit this way. This distance plus this distance equals all those other distances. So I can try to draw to the best of my ability. Again, I am not an artist. An ellipse. So every single one of these points were used using this tension of this string because the sum of both of these distances are always going to be equal. So again, like I said, this point right here was a focus, and this point over here was one of our foci. So let's talk about some of those. Okay, I don't know why you guys are commenting your names. It's okay. Just watch. Okay, so this right here, this line, is going to be your major axis. So it is the line that goes through your two different focus points. So we're going to talk about that some more as well. This is your focal axis. So the middle of this is going to be your center, just like any kind of circle had a center. So right here is going to be my center, roughly, I'm guessing. So it is going to be the center of both the focus and the center of these endpoints over here. So these are endpoints of your ellipse. So we also have another axis. So again, like I was saying earlier, this is your major axis. So this right here is your major axis. So if we were to make a perpendicular line through the center of that focal axis, this one right here is your minor axis. So major axis, the long one, minor axis, the smaller one. So these are also going to be endpoints. So they're typically called minor axis endpoints. These over here are your major axis endpoints. Okay. So sorry, I'm trying to look at your comments as best as I can. You guys are, again, just writing your names. Cool. All right. So this is basically, again, an ellipse. You can draw your own ellipse at home as long as you have a string and you have some tape. You can make a beautiful ellipse or whatever. So we're going to go and start talking about the equation now. So the equation for an ellipse that is centered at 0, 0 is going to be x squared over a squared plus y squared over b squared equals 1. So this formula should somewhat look a little bit familiar. It's because the circle, so if you remember your circle equation, that's x squared plus y squared equals r squared, where you get the radius. So if I were to have divided everything by this r squared factor, that's what's going to give me this 1 over here, but it's going to also tell me that a and b are equal. So this is a circle. So if I had divided everything by this r squared value, this would have canceled to 1, giving you the same equation, but these two are going to be different for an ellipse because we want one side to be longer and the other side to be shorter. So one thing you need to make a note of is that your a squared is always going to be your largest value. So this a squared is always going to be the largest value. So whichever the largest value is under, so whichever it's in the denominator, it tells you what type of an ellipse you're going to have. So if it's under the x squared, we're going to get more of a wider ellipse. If the a squared is under the, so this is when the x squared or the a squared is under the x squared. If it's ever under the y squared, you get more of a elongated ellipse. Okay, so let's see. So back to our, if I have my drawing, I don't have that big of a board, so I have to erase things. Sorry. Pause, do whatever you need to do. So here is my beautiful ellipse where I have 2 focus points. So from the center to the major axis endpoint, this distance right here is going to be an a value. So it's your a value. So that's the piece that's under here, but notice that it's squared in the equation. So please make note of those squares in the equation. Your b value is going to be from the minor axis endpoint to the center. So this distance right here is going to be your b. So that means that the overall length of your major axis, this focal axis right here, is going to be 2a. So this whole distance from here to here is going to be 2a. And then from here to here, your major axis is going to be the distance of 2b. Because again, it's the distance from the center to that major or minor endpoint. So I would ask if you guys have any questions at this point, but I don't know how that's going to work. Cool. Okay. So again, major things that we need to understand, whichever is the largest value, whichever denominator has the largest value, that tells you which way it's going to open, if it's going to be wider, if it's going to be more elongated. Also, Excellent. Cool. All right, awkward or not, I don't know. This is weird having to talk to myself, but we're getting used to it. So also that the total length is 2a, so if you cut it in half, that would give you your a. Same with your minor axis, this total length is 2b, so if you cut that in half, you will find your b value. Also, please note, to find the center of things is again just the average of points, because you just need to find the middle, and average is the middle. So let's look through. So one thing that you guys hopefully saw when you were looking at this lovely chart was that we have a Pythagorean relationship. So this Pythagorean relationship is going to be very important. So this C is actually going to be the distance from the center to the focus. So let me draw that for you, if I can remember where things went. So the center to the endpoint, so this distance right here, is going to be your A. There's a blue one. The center to the minor axis endpoint is going to be your B value of that Pythagorean relationship. And lastly, to the focus and center, this value right here is going to be your C value of the Pythagorean relationship. So if you look at these numbers, or these letters, you can see that A is going to be the longest. So that means that that A is going to finish off this as the hypotenuse. So that's why it's a little bit backwards of it being A. Oh, that didn't work. So that's why it is A squared equals that B squared plus C squared relationship, which is a little bit backwards using your letters. But again, A is the longest distance. That's why it's your hypotenuse of this triangle. And this is going to be very important for us when we are trying to come up with equations, because typically we may be given the C value and maybe a B, and then we need to find A, so forth and so on. All right. So let's do an example. So that first example on the slide. Oh no. So remind me not to use the colored markers next time. All right. So the example says find an equation with an ellipse that has a foci. So we know we have a foci at 0, -3, and one at 0, 3. We also know that the minor axis has a length of 4. So we are trying to figure out which equation to use. So again, like I've been telling you since the beginning of this class, always sketch something out. That way we can try to figure out which way this may be opening, if it's going to be longer, if it's going to be taller. And also, we always need to find the center of things. So I'm going to do a quick little sketch over on this side. So we have the point 0, -3. So 0, -3 would be about here. So this is one of my foci points. We also have it being at 0, 3. So here's another foci point. So again, the focus is always going to tell you, so as you can see, this is a vertical focus axis. So this is going to look something more like a taller ellipse. So because it's going to be the taller ellipse, that means my a squared value needs to go under the y squared of the equation. So I'm looking at the equation x squared over b squared plus y squared over a squared equals 1. So again, I'm getting that because that we have a taller ellipse, because this is a vertical focus line. So our vertical or focus axis is vertical, telling me I need to put my largest value under the y value. All right. So to do this, we need to find a and b. So that's all we need to do right now, because the center of this thing is going to be the center of these two focus. But since this is the first example, our center is at the point 0, 0. So we also know that the total minor axis length is 4. So this length right here, from here to here, is going to be 4. So the minor axis, so again, I'm looking for what A equals, what B equals, and I may need C in order to find A and B. So the minor axis length was 4. So that tells us that 2b equals 4, because the total length of our minor axis is 2b, and our total length was 4. So I can solve for b, divide both sides by that 2, and I get b to equal 2. So a is going to be the total distance from the center to the major axis endpoint, which is something I don't have from this information. But I could find C, because C is just the distance from the center to the focus. So I just need to find the distance from the center to this focus point. So I'm trying to find the distance between, so the center was 0, 0. The focus point, one of them was 0, 3. I'm trying to find the distance between these 2 points. So the zeros are the same, so I don't care about them. I need to just find the distance between 0 and 3. The distance between 0 and 3 is just 3. So I have B, I have C, I just need to find A in order to finish off this problem. So this is going to be a Pythagorean. So that is A squared equals B squared plus C squared. So I don't know A yet. So B was 2, so this is 2 squared. C is 3, so 3 squared. So A squared gives me out 13. Notice I don't need to take the square root of that, because A squared is actually in the equation itself. So since A squared is in the equation, I can just drop that 13 in there. So to finish off, since I know, or just write it off over here. So this is going to be x squared over b squared. B was 2, so 2 squared is 4. Plus a squared was that 13, and that equals 1. So this is it. That was the answer. So I needed to figure out the lengths between my center and my endpoints, which I didn't have the major one, so I needed to do my Pythagorean identity to actually go and help me find that. We found C, finding the distance between the center and the focus. And also the minor axis, we used the idea that 2b is the total length of the minor axis, so I could find b, which was just 2. So I'm going to take like 3 seconds for you guys to just write down whatever, maybe a little bit longer than 3 seconds. Ask any questions or look at the chat real quick, and then we will go on to the next equation or next question. So for the most part, you guys were saying no questions, so let's move on to the next example. So Ansley, the 2b is your minor axis, so that's always going to be the opposite of whichever way it is forming. So if it was tall, your 2b is going to be over here. If it was wider, your 2b would be vertical. So it's always the smaller of the two. Hopefully that answered your question. All right. So next up, we have find an equation of the ellipse with a major axis endpoints of plus or minus 6, 0, and whose minor axis is 8. So on this one, it also wants us to sketch the result. The last one did too, but I'll show you how to sketch these quickly. We're going to use the idea of the major axis and the minor axis kind of making a box that we could then kind of make an ellipse. So our major axis endpoints, we're at plus or minus 6, 0. So it just says that one's at 6, 0, one's at negative 6, 0. Just a quicker way of writing it. We also have a minor axis length of 8. Okay. So again, sketch this so we can kind of see what this is going to look like. So 6, 0 would be somewhere over here. So this would be one of my major axis endpoints. So do MA. Over here would be another one of the major axis endpoints. So because these are my major axis endpoints, this is going to tell me that this is going to be one of the wider ones, because major axis is going to describe to you which is going to be your A value. So since this is going to be wider, that means we're going to have our A under the x squared. So our equation we're making is x squared over A squared plus y squared over B squared equals 1. Because again, this is going to be more of a wider ellipse. So we also know that the minor axis is going to be a length of 8. So that means that the perpendicular to that major axis is going to have a length of 8. So this total length over here is going to be 8. So there's a couple things that we could do. We need to find A and B. So again, we need to find what A equals, we need to find what B equals. And we can do that first. Let's find B, since that's going to be quicker, because we already know the length of the minor axis to be 8. So I can again say that 2B equals 8, because B is going to be my minor, and 2B is that total length. So then B just equals 4. I need to find the minor axis. So you can find the distance between both of those points. So from the positive 6, 0, negative 6, 0, to find what 2a would equal. I wouldn't recommend that though. I would always just go from where the center is, because again, the center is just the middle. And the middle between 6, 0 and negative 6 zeros is again at 0, 0. So we can just find the distance between the center from 0, 0 and from, let's say, 6, 0. So again, these zeros are the same, so they don't matter. I'm only trying to find the distance between 6 and 0. Again, it's distance. Distance is always positive. So if you had chosen negative 6 instead, again, just make it a positive distance. So the distance between 0 and 6 is just 6. So that means my A equals 6. And we're done. We can now just plug in A and B into the equation. So A was 6, so A squared is going to be 36. b was 4, so b squared is 16, and that equals 1. Again, that's it. So we didn't care about our focus points at this point. We can use the fact that we now know what b is and what a is to make this drawing a little bit better. So I'm going to do that just for your sake so you can see. So here is one of my major axis points. Here's another one. So we know that b is going to be a distance of 4. So if I start at the center, I can go up 4, and I can go down 4, and those would be my minor axis endpoints. So I'm just going in either the opposite of it being horizontal, which would be vertical, so I'm going the vertical distance of 4 from the center up and down it. So now what I can do is I can draw kind of like a little box. So my ellipse is going to look something like this, as best as I can draw. What's the top and bottom ends of the ellipse? So we don't have to find c always because c is not in the equation itself. So I only had to find c last time because I was given a focal length, and the distance from the center to the focus is that c value. And I wasn't given this major axis endpoint of being that a value, so I had to find a using c. So a lot of times if you have information already on the major and the minor axis, you're going to be good. This should be a very straightforward problem. Otherwise, if you're given a focus instead of one of these two values, then you are going to have to do a little bit more math to find that a or b value using c. But if you have a and b, because major axis is going to give you your a, your minor axis is going to give you information on b. So using those two, I don't need c because it's already a and b only in the equation. There is no c value in this equation. Brandy, to answer your question about what is the top and bottom ends of the ellipse, I think so. I don't quite understand your question. Those are just endpoints, so they're either going to be your minor or major axis endpoints, depending on how it looks. So this top would have been a minor endpoint because it's shorter than the major, and this one down here is also going to be one of those endpoints. I don't know if that answers your question because I don't fully understand it. Let me know if that answers it. So Faith, the 2b piece is going to, so anytime you have a length of either the minor or the major, so 2b always equals the length of the minor. 2a is going to be the length of the major. So that's just always true because the total distance is double the a or b value. Because from the center to this minor is a b, so I actually have 2 b's to go from top to bottom. So that gives me the total length of 2b. Same with over here, this is a distance of a, this is a distance of a, so 2 of them together gives me 2a for that total major length. Hopefully that answers your question, Faith. So, Shauna, so we were given major endpoints. We weren't given focus. So C is only dealing with focus points. So since we weren't told anything about our focus length here, we don't know any of those values. You can solve for C if you really wanted to using A and B and the formula. So you could have said, hey, A was 6, so this would have been 6 squared equals 4 squared plus c squared, and you can solve for c. that would give you the square root. So 2 root 5 would be what C would equal if you solve that out. Again, that's not necessary for this problem. C is, again, only if you see the word focus. If you see the word major axis, that's going to be some kind of A value. If you see minor axis, that's going to be some kind of B value. Hopefully that answered your question, Shauna. So, Abby, the maximum, so there, I wouldn't use the word maximum. I would use the minor axis endpoint would be here at 0, 4 and at 0, negative 4 because I'm using the B value of 4 like you were saying. I'm going up 4 from the center and down 4 from the center. But I wouldn't call those extremes like you were saying. Okay. All right. So, again, I'm going to give you guys a couple seconds to kind of look through this, ask more questions, or try to answer any more questions that you guys post, and then we will move on. We only have 2 more examples, but these are with our centers being not at 0, 0, but it's the same ideas. So, again, I'll give you guys a couple seconds, or look at the group chat and answer more questions. All right, so a summary of the steps I did. So for this example, at least, what I did was first I sketched it. So after I've sketched it, I could see that this is going to be a wider ellipse because my 2 major axis endpoints were horizontal between one and another. So that means that I was using the equation where my a squared, my largest value, should be under my x squared. Because again, x being your left and right, so this is a left and right kind of parabola or ellipse. How many times have I said parabola? Okay, whatever. After that, I used the fact that the length of the minor axis was 8, and the length of the minor axis is always 2b, because that is your total distance, so I could easily find b by just dividing 8 by 2, so that's how I got that 4. Then I just needed to find a. Unlike the last example that gave me a focus point, that's why I had to go and find C first, but now I was given a major axis endpoint, which is 100% better, because then I can go straight to finding the distance from the center to that major axis. So my center was at 0, 0. So the distance I had to travel from 0, 0 to get to 6, 0 was a distance of 6. So that was my A value. So after I had A and B, I simply plugged them in and squared them, and I got my answer. Hopefully those steps make sense to you. Okay, so on to the next. So this is when our center was always at 0, 0. So just like with our parabolas, we're going to be moving our center around using that H and K format. So the only difference with our equation is where our x squared was, we're going to have a parentheses x minus h. Where our y squared was, we're going to have a y minus k squared. And that h and k is always going to be your center values. So again, this is where I'm looking at either the x minus h squared plus y minus k squared equals 1. Where whichever one A is under, that's going to, again, determine if this is going to be a wider parabola or a taller parabola. So in this example, since A was here, this would have been a wider one because it's under the x. And again, please note that we have built-in minuses into the equation, which means our center is always going to be the opposite. So if my center was 3, 2, this would be an x minus 3 and a y minus 2. So again, the minus is built into the equation. So especially if you were ever given an equation and you're asked to pull out information, which we will do later, you need to remember it's going to be the opposite number. Okay, so let's do an example because again, otherwise it's going to be the exact same thing. We are going to sketch a picture, determine which of the two equations does A need to be under X, does A need to be under Y, then we need to find the center. So unlike last time where the center was just always 0, 0, we need to find our center first because we need to be able to plug in H and K. So we're going to do some examples where we're going to find the center, find A, find B, which by whatever means necessary. So, first example. So it says, find the standard form of the equation for an ellipse whose major axis has the endpoints of -2, -1. So we have, again, a major axis endpoints of -2, -1, and 8, -1. We were also told that the minor axis has a length of 4. So minor axis has a length of 4. 8. 8. All right. So again, sketch a picture because maybe you don't know based off these points, should this be a wider or be a taller ellipse? So let's sketch a picture. So -2, -1 would be somewhere about here. 8, -1 is going to be somewhere over here. So these are, again, my major axis. So your major axis is going to define your A term. Your minor axis will define your B term. So this is telling me that my ellipse should be a wider ellipse. Because again, these are endpoints. So that means that they are at the ends of the ellipse. So we can go and we can quickly find our B value because again, minor axis length, that's saying, hey, this is going to be whatever 2B is. So that means my B value is going to be 4. So we've already found our B to be 4. So I still need to find A and I still need to find my center. Because my center is going to be my H and K value that I still need to plug into my equation. So we can do that. We can find the center using this information. So I'm trying to find the center. So the best way to find the center is, again, I'm going to look at these major axis lengths. So this is, I'm trying to find the middle between -2, -1, and 8, -1. So if you guys remember your midpoint formula, which you do, that is going to be x1 plus x2 over 2 and y1 plus y2 over 2. So I'm literally just taking the average of my x's and my average of my y's. So again, average, middle. To find the middle of something, to find the average of something, you add up all of the values and then divide by the total amount. I have 2x values, so I'm going to add them together and divide by 2 because I had 2 of them. Same with my y values. So doing this piece of information, this would be -2 plus 8 over 2 and -1 plus -1 over 2. So this gives me the point 3, -1. So this is my center. Because again, I found the middle, the center, between these two major axis endpoints. So we just found our center to be 3, -1. So I need to still find A. And A is the distance from the center to one of those major axis endpoints. So I need to find the distance between my center, which was at 3, -1, and my major axis, which was, let's pick one of them. I'm going to use 8, -1. It doesn't matter which one you pick. Just make sure whatever value you get is going to be a positive value. So again, because I'm finding the distance, these two are the same, so they don't matter. I just need to know the distance between 3 and 8. And the distance between 3 and 8 is 5. I had to add 5 to go from 3 to 8. So that means my A value is going to be 5. So A is the distance from the center to the major axis endpoint. It didn't matter which one you used. You should have found that the distance was 5. Our B value we found using, again, the fact that the minor axis length is 2b. So 2b equal that 8, giving me b of 4. I also found my center by taking 2 points and just finding the middle of them by doing the midpoint formula. So using all this information, we can then plug it in. So this is going to be x minus 3 squared over a squared, so that 5 squared is 25, plus y minus k, so y minus -1 gives me y plus 1 squared, over b squared, which was 4, so 16 equals 1. So again, I'm going to just briefly go right over it again, and then I'll look at the group chat to see if you guys had any messages. So I sketched it. So after I sketched it, I saw that the major axis endpoints were on a horizontal line. So that told me that the a squared needed to be under the x squared. So I'm using this equation. So then what I did was I found the center. So the center is just the middle of any 2 points. So any 2 of the same points. So if I had 2 major axis endpoints, I could find the middle of those. If I had 2 minor axis endpoints, I can find the middle of those. If I had 2 focus points, I could find the middle of those. So the center is always just going to be the middle of 2 of the exact same type of point. So that middle is just using the midpoint formula, which is just using the average. So you average up your x's, you average up your y values, and you got your center. We used, again, the fact that your minor axis length, the total length of your minor axis, whichever direction it is always 2b. So we set 2b equal to that 8, found that b was 4. So then we needed to still find a. And a is the distance between the center and a major axis endpoint. Again, whichever one you picked is fine. Just make sure your distance is positive. So we saw that the -1s were identical, so those distances weren't going to affect us. Only the 3 and 8. So to go from 3 to 8, it was a positive 5. So that was my distance. So then I just plugged them into my formula. So again, I'll give you some time to write down this information. I'm going to go and look at the group chat to see if there are any questions that I can answer further. So, Abby, distance is subtraction. So we subtracted that 8 and 3 to find 5. So again, distance is subtraction. All right then, so let us do another one. So, all right, so on this question, yes, distance is always positive. So again, however you do a subtraction, it doesn't matter. Just make it positive, do an absolute value, because again, distance is always positive. So even if you got a -5, hey, absolute value, +5, you're good. Okay, so we want to find the standard form of an equation whose major axis has endpoints at -2, -1, -2, 7. So again, we have a major axis at -2, -1, and -2, 7. We also were given foci points this time. So we were given foci, one at -2, 1, and at -2, 5. So again, major axis is telling you information about your A value. Focus are going to tell you about the C value. So we aren't given anything about our minor axis this time, which means we're going to need to use this C value to help us find B. So first, let's do a quick sketch to see which way that this ellipse may be. So doing a quick sketch. So -2, -1 would be somewhere about here. -2, 7, somewhere around here. So here are my major axis endpoints. My focus is -2, 1, and over here, so here are my focus. So notice how all of these points are on a vertical line. So your major axis and your focus are going to tell you information about which your A should be under. Since this is a vertical line, all of these line up. That means that our A value is going to be under our Y this time. So again, I need to find information. I need to find my center. I need to find my A value. And I need to find B. So this time, I'm going to need to use C to help me find B. I'm going to need to find C to help me find B. So we're going to start by finding the center because we need the center to be able to find A and C. So it doesn't matter which two you pick. You can do the major axis, you can do the minor axis. So whichever ones you pick should be fine. So I'm going to pick the major axis ones. So I'm going to find the center using my major axis. So I'm going to, again, take the average. So the average between -2 plus -2 over 2 and -1, 7 over 2. This gives me the point -2, 3. So my center is at -2, 3. And if you had used your focus instead, you would have found the exact same information. So here's my center. Again, I just used the midpoint formula, which means I'm just taking the average of my x's, the average of my y's. So my center is at -2, 3. So again, to find A is the distance between our center and one of our major axis endpoints. Doesn't matter which. So I'm going to find the distance. So here is information about me finding A. So my center was at -2, 3. One of my major axis endpoints was -2, 7. So the -2's are the same, so the distance between 3 and 7 gives me an A of 4. So again, I'm just trying to find how can I go from the smallest number to the largest number. It doesn't matter. -2's being the same means there's no distance between them, so I don't have to do any fancy math. I just have to find what is 3 plus what is 7. Okay, so I also need to do this with C as well. So C is the distance from the center to one of your foci points. So again, it doesn't matter which one. So again, my center was -2, 3. My focus point, I'm going to choose -2, 1 this time, because why not? So again, your -2's are the same, so that distance doesn't matter. And the distance between 3 and 1 is just 2. I have to go a distance of 2 to go from 1 to 3. Again, positive. Just make it positive. So my C value is 2. So we're going to now use that Pythagorean identity to help us find B. Just remember, it is not A squared plus B squared equals C squared. Using these letters, I know it's very confusing, but your A is always the hypotenuse. It's always the longest distance between all of them. So that means this is going to be the A squared equals B squared plus C squared. So we have 4 squared equals B squared plus 2 squared. So 16 equals B squared plus 4. So subtract that over, we get 12 equals B squared. So again, we don't have to take the square root of that, because in the formula itself is a B squared. So I could just use that fact at this point and just put it up there. You can simplify it if you really want to, waste your time, and then try to square it, and then when you put it in your calculator, you messed it up because you forgot to put it in parentheses. To be honest, I've seen you do it. So I'm just going to keep it as B squared because B squared is in the equation. So now that I have all this information, I'm just going to plug it in. So again, my center, my x goes with x, so x minus -2 gives me a positive 2 squared. My b is under my x this time. My b squared was 12, so 12 goes under here. Plus y minus your k value, which was 3, squared, over a squared, a being 4, so that gives me 16, equals 1. And again, notice your a should always be your a squared should always be larger than your b squared. So here is our answer for this problem. So again, I'm just going to talk through it one more time, just so you have all this information. So we sketched our major axis and our focus endpoints. We saw that they were a vertical line. Because it was a vertical line, I knew that my a squared needed to be under the y squared, because vertical is y. The first thing I did was find my center, because I need my center to help me find other pieces of information. And again, the center is just the average of x's and y's. It doesn't matter which 2 points you picked, just make sure they are the same kind of thing. Don't go and use one for major and one for minor. So it doesn't matter, you could have used your focus points and you would have found -2, 3 to be your center. We then used that center to help us find A and C. So the distance between the center and the major axis gives you A. The distance between the center and the focus gives you C. We then used that nice Pythagorean identity to help us find what B squared was. We didn't try to simplify it, we just then put B squared into the equation. Okay, so again, we're going to look at this real quick, give you some time, look at any of the questions you've already posted, and then we have just 2 more quick examples to go through. They're a lot quicker, and then we will be done for the day. Sorry this one was going so over. Okay. So let's look at this next example. We're going to be going backwards this time. We are given the information and we want to find the center, the different vertices, and the foci. Okay, so the example for this one was x plus 2 quantity squared over 9 plus y minus 5 squared over 49 equals 1. Okay, so we're going to be working backwards this time, so we're going to use the equation to pull out information. So there's three things that you need to pull out. So the first is going to be the center. So we can find the center. So remember, the equation has built-in negatives into it, which means when we pull it out, it's going to be the opposite number of whatever you see. Also, x goes with x, y goes with y. So looking at my center, I'm going to be pulling out a negative 2 and a positive 5. So again, remember, the equation itself has a built-in negative. Two other pieces of information I need to be able to pull out are going to be whatever a and b are. So using a and b, we can then find all other pieces of information. So a is always going to be which of the two is going to be the larger. So looking at this, that 49 is larger than 9. So my a is going to come from this 49. So my b has to come from this 9. But remember that this is actually a squared and this is b squared. So I just need to take the square roots of these two numbers to find a and b. So a is going to be 7, b is going to be 3. So also I know because my a is going to be underneath my y, this is going to be a vertical ellipse. So this is going to be one of the taller ellipses, which means that from my center, both my focus and my major axis endpoints are going to be above and below it. So that means to move up and down, we're going to be using our a and b values to help us do that. Okay. So we're going to start at our center. So let's find our major axis information first. So I'm going to be starting at my center, which was negative 2, 5. Then I'm going to be using this a value to go up and down from this center. So because again, we know this is a vertical one, that means my major and my focus are going to be going up and down. My minor is going to be going left and right because my minor is under my x. So using this 7, that means I need to be going up 7 and I need to be going down 7 from my center. So up and down is, again, something that's going to affect my y values. So my x values are not going to change because if you've seen in all of the previous examples, one of the two coordinates are always going to be identical. So this is going to be negative 2 and 12. And down here, we will have negative 2, negative 2. So I have two major axis endpoints. We have one at negative 2, 12, and we have one at negative 2, negative 2. Again, I was using my a value to go up and down that distance. So let's go and do our focus next. So I want to do my focus points. To do my focus points, because again, On the major axis also lies the focus, which means I'm going to be moving up and down, but I need C in order to find my focus points. So major axis is again your A value. Focus is going to be your C value. And to find C, we're just going to use that Pythagorean identity again, where A squared equals B squared plus C squared. So this is 49 equals 9 plus C squared. So I can subtract this over, and I would get C equals the square root of 40. So I'm going to simplify that. I'm going to change that to be 2 root 10. So I just simplified that radical. There was a 4 inside of it. The square root of 4 is 2. 4 times 40 is 10, so 2 root 10. That's what I was left with. So again, using my center, which was negative 2, 5, I need to go up and down my focus. And that means I'm going to be going up 2 root 10. I'm going to be going down 2 root 10. One of the nice things about these being square roots is that I can't actually add them together, which means they're just going to be listed as, so we have negative 2, 5 plus 2 root 10, and I would have negative 2, 5 minus 2 root 10. So I went up 2 root 10 and down 2 root 10. So I can't add this 5 and negative 2 root 10 together. Do not do it. Do not write that as 3 root 10. Don't do it as whatever else I've seen you guys do in the past. Please. One has a radical, one doesn't. These are not like terms. You cannot add them together. So we just found our focus points. One being negative 2, 5 plus, I'm just going to write it as 5 plus or minus 2 root 10 to save myself time. Because that's what I did. I went up 2 and down 2. So the last piece of information that it was asking for is my other endpoint. So that's going to be the minor axis endpoints. So this is going to be using your B term. Again, everything is coming from the center. So you need to have your center first. So as you can see, these two were vertical because our A was under our y squared. So your focus and your major axis both go in the same direction. Your minor axis, on the other hand, does the opposite. Since our minor axis was under x, this is going to be going left and right instead. So that means I'm actually going to be adding 3 to my x value and subtracting 3 from my x value. So giving me the points 1, 5, and giving me the points negative 5, 5. Because again, minor axis is the opposite of major axis. So since the major axis was vertical, minor axis is horizontal. So our final answers for these. So 1, 5, and negative 5, 5. So again, a quick recap. So we took out the center first. So I found that the center was negative 2, 5, because again, the minus is built in. X with X, Y with Y. I then determined which of these two was larger, 49 or 9. And since 49 was larger, that's going to be my A squared term. Since 9 was smaller, that's my B squared term. So then I found A and B. I also needed to find C, so I used this Pythagorean identity. I simplified that radical. So we also knew that since our A squared was under our Y, this is going to be a vertical ellipse, which means I'm going to be adding and subtracting the distance of this 7 to my center. I'm going to be going up 7 and down 7 because that was the distance from the center to that endpoint. So I went that distance, both positive and negative, to find those two endpoints. So then for my focus, I'm going to be using C instead, using that distance, which was that 2 root 10. So I added and subtracted that to my center. Again, going vertically, because major axis and focus are all on the same line, which was a vertical line. Then the minor axis, which is going to be the opposite, so that means it's horizontal. Again, I'm using the center. I'm just going to go right 3 and left 3 instead. So my y values are going to stay the same. So that gave me all those pieces of information. So I'm going to, again, give you guys some time, look at any comments, try to answer any questions, and then talk about the very last piece. So the answer on the slide had the decimal version. If you're in regular pre-cal, you can just give me it as a decimal. If you're in accelerated, I better see these exact answers. Okay. All right. So the last thing for today is a quick idea. It's not too much math involved. It's talking about eccentricity. So that tells you how off-center your ellipse actually is. So the equation for eccentricity is simply going to be C over A. So it's a ratio. So it's a ratio between your focus points and your actual vertices, your major axis endpoints. So C again is your focus points, the distance from the center to the focus, and the distance from the center to the endpoint is your A, your major axis endpoint. So this is a ratio to tell you how off-center something is. So if this value is ever 0, so if you ever get out 0, this is just a circle. And it's just a circle because basically you're saying that your focus is at the center, meaning both the major axis length and the minor axis length are actually identical. So you would get a circle out. So the closer it is to 1, the more off-center it is. So if C gets really close to those points, that means it's going to be closer and closer to 1. So really, to find the eccentricity, it's just simply using that C value divided by A, and that just gives you a little bit of information. So one of the examples basically is just telling you that the eccentricity of the Halley's Comet is 0.97. So because it's 0.97, that means that your focus point is really close to your actual endpoint. And that's one of the reasons why it takes 75 years for us to see Halley's Comet, is because we only get to see it right at this point when it's really, really close to us. The rest of the time, it's traveling all the way over here. So that's why it takes so long for it to come back around to us, because it's really far off center. All right. So that's all I have for you today. I don't know how many homework problems there are, but there's probably just 15 or so where you're just using different pieces of information to find the equation or taking information from an equation. So again, I just need to reiterate, we are going to be doing this every other day, just like it's a regular class. That's the expectations moving forward. So if you have any homework questions as you're doing them, feel free to shoot me a remind. You can take a picture of your work and say, I'm stuck at this part, and I will try to answer you as quickly as I possibly can. But also, that's what recitation is for as well. So those Thursday night sessions we're going to do is where all of you can come and ask questions. It could be questions over the homework, or it could just be questions in general, so you guys can just sit and listen to other questions people have asked to maybe help yourself. Or if you have homework problems, we can look at those as well. Maybe or do a couple more examples just to try to help you guys out. Please, if you have any questions or comments or ideas to help this move a little bit smoothly, please shoot me a message through a remind so I can think about it, because I'm just trying to help you. And yeah, I'm just by myself right now, which again is extremely weird because I don't get that same feedback from all of you, and I can only look at these questions every once in a while. So please, let's try to work together to make this as smooth as possible. So that's it. I think people say like and subscribe. So, bye. Oh, yes, I will. Let me go and bring the baby real quick. You've never been in this room, have you? So, there's the camera. People are watching us right now. So, He's a little fussy boy today. He's got more teeth coming in. He now has 4 teeth. 2 in the top, 2 in the bottom. You gonna learn math one day? You gonna be like Dada? Yeah. So, you wanna wave to the people? Wave. 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 A wave. A wave. Yeah. Alright. So, this is Hayes. He's 8 months old. Yeah. Big boy. Big boy. Alright. So, okay,